Good morning and happy Friday, seventh graders. This is Oliver bringing you today's lesson on constant rate of change. So, Thursday, you had a lesson starting this, and today's just building on with that and making sure for sure that we do understand what we're trying to find when we're asked to find a constant rate of change. Okay, so yesterday, our objective is still the same. We want to represent and identify the constant rates of change. Remember proportional and non-proportional relationships and how we use those to find if a table or graph is proportional kind of helps us with finding out if something, what our constant rate of change is. Okay, so you're going to put this in after yesterday's notes. We're still in part page 50. This is in your textbook of what we're doing today, so you're not going to actually glue it in. So these are steps if you want to know, hey, what are each step I have to do? So we could check the ratios, and if it is proportional, the unit rate will equal our constant rate of change, also known as CROC. Okay, but if it is not, we can check the change in each variable. We can set up the ratios if equal, and then that will make our unit rate. If 1 and 2 don't work, then we can show equal ratios. There is no constant rate of change. So let's look at examples from our book. Okay, so we have a table, and they are telling us, hey, we want to find the amount of money a booster club makes washing cars for a fundraiser. Use the information and find the constant rate in dollars per car. So this is the method I showed you yesterday. You could use that for step 2. But hey, it's proportional. So we have 40 over 5, that equals 8. 80 over 10 equals 8. 120 divided by 15 equals 8. These all are proportional with 8. So right there would tell us that our unit rate, in fact, is 8. But like we've seen before, not every linear line, linear meaning it is straight, is going to, not every linear line is going to be proportional. So we have to pay attention and figure out if we can find out if it's proportional. Or you can always do the second way, and that will tell you if you're good. Okay, so we find the unit rate when we went through this. So we had, it goes up, changes 40 from our y. Remember, we're always taking our change in y over our change in x. And then it went increased by 5, adding 5 every time. So that tells us our unit rate then, when we go from this point to that point, is $8 per car. So then the number of dollars earned increases by 8 for every car washed. Well, that's an example in your textbook. There are multiple examples. Okay, so then we have this table. We could check to see. Okay, step 1, we take our y's and divide it by x. We don't always get a proportional. Remember, x is always on top and y is always on bottom. But since they're not equal, we kind of have to go to step 2. And step 2 is where I take and figure out, okay, so how did we change going from here to here? Well, I had to add 25. I added 25. So I know it's linear because we have a constant change. And this each time went up 1, up 1, up 1. So that's how we got our 25 over 1. Okay. So we're going to do some guided practice on page 68. You have 3 problems to do, and then you can start your homework. Okay, the table and graph show the amount of money Millie and Daniel saved each week. Who saves more money? Okay, so when we looked at Millie, we have how much do we increase? We increased by 15. I increased by 15. And then I only increased by 1. Well, which one's going to go on top when I go to make my gains info? Well, remember it is y over x. We're changing y over changing x. We changed by going up 15, and then we changed by going up by 1. So my unit rate is $15 per 1 week. So what's my constant rate of change? It is $15 per week. Remember, that's where we want to find a unit rate. And remember, unit rate has to have 1 for the x in the denominator. That is how you know you have your unit rate. Okay, so then we want to look at Daniel. Okay, so he goes up 10 and then over 1. So this is 10 and 1. Up 10 over 1. Up 10 over 1. Up 10 over 1. All right, so we have his change in y and change of x equals $10 per 1 week. And that can't be reduced. It's already in its unit rate because we have a 1 in the bottom. So we know his CROC, his constant rate of change, is $10 per week. So who saves more money? Well, our explanation would be that Millie saves more money because he saves $15 per week and Daniel only saves $10 per week. I think you need to pause this before we go down to number 2. All right, so we want to refer to the graph. So we're coming back to the graph, and they want to know, what do the points 0, 0 and 110 represent? What are those? Well, remember, we graph data. That is what is being put on here, is the data. So at 0, remember, our ordered pairs is given to us as weeks and savings. That's how the order pair is. So we would want to say at 0, 0, at the very beginning of this, has he saved any money? No, because it hasn't even started. So 0, 0 represents $0 saved in 0 weeks. Then we got to talk about, what does 110 mean? Right? X at 1, Y at 10. This represents that Daniel saved his $10 in 1 week. All right, one more question and then we'll look at the homework. Okay, building on our essential question, how can you find the unit rate on a graph that does go through the origin? Well, what is the unit rate? Unit rate is when x is 1. Okay, when that 1 is on the bottom of your equation, your fraction. So we go to when the y coordinates where x is 1. So you find x is 1 and you go up until you hit the line, and whatever the y is for your height, that's your unit rate. Okay, so for Daniel, his unit rate is 10 because at 1 for x, the y value is 10. Oops. So let's scroll back up. Your homework Oh, I thought I fixed that so it says 7. You are doing 1 through 7. Okay? So make sure you're looking at how are they changing. Remember, X is always on the left, Y is always on the right. You want to find your change in Y over your change in X. So my change in miles over my change in time. How are we changing each time we hop? Well, each time I'm going up by 6. So it gives me my 6. And then how am I changing each time here? We're changing by 1 each time. Okay, can that be reduced at all? Nope. So that means our CROC is 6 miles per and S per second. All right. Then number 2, you're going to do the same thing. Number 3, we're looking at the graph. Make sure you find what your constant rate of change is, and then it says explain what the points represent. Look at the very last thing that we just did in our guided practice. That will help you with answering that question. Okay, otherwise finish up the remaining of the questions and you have a great weekend.